Our main topic for today is exceptions, which we're going to spend some time talking about. But before we do that, I would like to look at something in Lab 7. In Lab 7, you're supposed to create the necessary classes for the following situations. Use inheritance. A library has patrons that check out a variety of materials, and we said books and DVDs. All books have an ID, a title, an author, date checked out. All DVDs have this. Both books and DVDs should have methods that can return those things. Due date, if overdue, fine based on return date. Finally, we have a little table here that says, that a DVD can be checked out for 7 days and there's a $1 a day fine. A book can be checked out for 28 days and has a 25-cent per day fine. Now, when you're creating these classes, it says specifically to use inheritance. Now, if you think about it, a book, can I say this? Can I say a book is a DVD? No, that's not a true statement. A book is not a DVD. Likewise, a DVD is not a book. Therefore, one of them can't inherit from the other one. We can, however, create a third class, a library materials class, and have these two classes inherit from it. So we have library materials and subclasses from that would be book and DVD. Now, we mentioned that some of the things are common for both. We mentioned ID, title are common for both. Therefore, that would be defined up in the superclass. Whereas author, and date checked out. These are three attributes that these two things share, and presumably any library material that you were able to check out would have an ID, would have a title, and would have a date checked out. So we'd have these along with the appropriate get and sets. All right. Author and rating, though, exist in the book and in the DVD. Now, finally, I've said that I should be able to ask each of these for the due date, if it's overdue, and what the fine is if it's overdue. Now, if we think about it, there's different ways to calculate if it's overdue or not. With book, you like to see if the current date is 7 days past the date checked out. No, with book, it's 28 days, I'm sorry. With DVD, you look to see if it's more than 7 days since the book was checked out. So there's going to be likely, I want to undo this. An is overdue function in each. Now we could do this a bunch of different ways, but more than likely there'll be an is overdue function in each. All right. However, any library material, we need to be able to check if it is overdue or not. But the rules for determining whether it's overdue or not depends on the specific piece of library material we're talking about. Is it a DVD? Is it a book? Is it maybe some other thing that you can check out of a library? Maybe like a magazine. All right. Therefore, if we instantiate a library material, if we don't define the isOverdue method also on the library material class, then we won't be able to have an array list of library materials, loop through them, and ask for each item on the list, is that overdue or not? Because remember, when we declare a variable as being of type library material, we can only call those methods which are defined on the library material class. And if we don't have an isOverdue method on the library class, we're not able to do that. Well, we want to be able to do that. If we have, for example, a list of an array list of items that a person's returning to the library, we want to loop through each one, see what's overdue, and calculate the fine for each of the materials, regardless if they're a book or a DVD. So, is overdue rather, calculate fine, and calculate due date would be defined here, and they'd also be defined for each subclass. Thing is there's no code we can put here because every library material, every different type of library material has its own rule for calculating the fine, has its own rule for calculating if it's overdue, has its own rule for calculating the due date. All right. But we want to have that method in the library materials. Essentially, if I were to create a third class, let's say magazines, that inherited from library materials, I would want to be sure that I've defined these three methods: isOverdue, calculate fine, and calculate due date. This is what we use an abstract class and an abstract method. First of all, library materials is an abstract class, which means that it contains code and attributes of things that all different pieces of library materials have in common, yet we're never going to create an instance of a library material. We're going to create a book, a magazine, or a DVD. Because if you think about it, when you go to the library, you don't check out a library material. You check out a book, a DVD, or a magazine. Yet this class has to have the methods in here to guarantee that anything that inherits these from this class implements these methods. So that's where an abstract class comes in. There's some rules about abstract classes. First of all, an abstract method must be contained in an abstract class. They show you how to declare an abstract class here. When you define an abstract method, you simply you put the word abstract in front of it, the name of the or what it returns, and the name of the method along with any arguments. So in that way, I could define, and I do it something like this. I would define public abstract library materials. Then I could declare all the attributes that are in library materials. Like maybe the ID number material. And so on down the line. I could also define an abstract method by saying abstract, it returns a local date, calculate due date. And in this case, it accepts no arguments. This isn't complete Java code. This is just sort of a shell of Java code that you'll need to fill in the blanks for. All right. So I would declare abstract methods of calculate due date, along with calculate fine, along with is overdue. Like this. Now, what that means is anything that inherits from this class, like these, either itself has to be an abstract class, or it has to implement those methods. In other words, it has to have a non-abstract version of is due, calculate fine, and calculate due date. So we define here to indicate that all library materials have this function. And then when we create the class, we create that function, except it's no longer an abstract class. It will be a concrete class. So I hadn't really talked about abstract methods yet or abstract classes in too much detail. So I wanted to go over that today. Okay. Up next, exceptions. And by all means, if you have questions at all, please ask me them. I can't tell you enough the importance of doing that. It's great that you want to figure out stuff for yourself, but you should not be spinning your wheels, not making any progress, and getting frustrated. So spend some time trying to figure out the issues you're having, or if you don't know where to begin, spend some time thinking about it. But if you get stuck, ask. That's what I'm here for. This is a blended class, which means that part of it takes place in person, but part of it also takes place online. And you have to meet me halfway, though. You have to let me know where you're having problems, and I can arrange times with you to meet online. All right, let me pull down the exceptions example from this week. There are a couple of videos about exception handling. And custom exceptions, which I urge you to review. Again, that's your responsibility to review the online materials for this class. Let's take a look at the exceptions. So far, we've pretended that we're always going to behave ourselves when we write code. What do I mean by that? Well, I mean, we make sure that we're not dividing by 0. All right. When we create our test cases, we make sure that there's not going to be any issue where we divide by 0. We make sure of that. Or when we did our student example, we made sure we gave each student a valid value for their residency code. So IC, OC, OOS, in county, out of state. But you know what would break that code is if we gave an invalid value. If we gave the word out, for example, instead of IC, OC, or OOS. Out would break the code because it's not one of the valid choices for that. Now, there's a few ways that you can handle it. One way to handle it is with exceptions. A short way to put it as an exception is when there is something unexpected and undesirable that happens within a program. So there could be exceptions for when there is a problem connecting to a database, for example. There can be exceptions when you try to divide by 0. There can be exceptions when you try to take a string and convert it into a number. All those things are potential for exceptions. And we want our code to be able to handle that. Right now, if there's an exception and we don't handle it, your program just blows up and dies. Let me look at these examples. Exceptions 1, 2, or 3. I'll try to get through all of these. If I do not, please take the time to review them along with the other online materials on your own. I have a class called Test Exceptions. Let's get into that and run it, and we'll take a look at it. Let's look at our source code and see what it does. All right. Here I've declared an array. And what I'm going to do is I'm going to copy the text here. And I'm going to show you what happens if we don't declare exceptions. Why am I getting an error? Oh, I'm in the wrong, am I in the right, oh, I'm in the right folder. Oh, no, I'm not. All right, I compile it cleanly. I go to run it. And boom, I get an error at line 15. It's a very popular error that you can get called null pointer exception. Let's see if we can look at that and determine what the error is. Line 15, it says null pointer exception. What that means is there's an object that I'm referring to on line 15 that doesn't exist. Well, what doesn't exist is because I set item 1 in the array to null. And then I ask for the length. So I null out item 1 in this array list. Yet I'm looping through and looking through item 0 through item 100. But I've set item 1 to null. If this item is null, then I can't get the length of that item because it doesn't exist. Remember, a null object is not like an object with spaces in it or with zeros in it. It's sort of like, what's the value of your savings account at First National of Alaska Bank? All right. You don't have an account at First National of Alaska Bank. At least I don't think you do. But you can't say your balance is 0. You literally have no balance. Your balance is null. Therefore, I can't ask for the length of that because it doesn't exist. So that's what this lines of code does. It breaks my loop and gives me an error when I is equal to 1. If I remove this, I'll get a different kind of error. I get an error saying that item 2 is out of bounds for length 2, and it's an exception. Well, because I'm running this array starting at 0 and going to 100, and there's only 2 elements in the array. So when I get to item 2 in the array, it blows up. These are unexpected, undesirable conditions, and they are exceptions. And someone has to handle the exception. If no one handles the exception, then the Java virtual machine will handle it by stopping execution of the program and just displaying an error like this. So I'm going to go back. We hit undo a couple of times. And I'm instead going to put my code in a try-catch block. Now, some of you might have seen try-catch blocks in C#. What that means is that we're going to try to execute this statement. If this statement comes up with an exception, we're going to handle it this way. And in this case, if it's a null pointer exception, we're going to print out this error message. If it's an invalid out of bounds exception, these are the two exceptions that I've gotten. No pointer, index out of bounds. If it's one of those two exceptions, it's going to display an error. Start out by only looking for the null pointer exception. Since we're not handling that exception, we get an error. It handled the null string at position 1 by displaying that. But since we didn't tell it what to do in the case of the other exception, we get an error. Here is a better example. We are handling both exceptions. Now if we compile it and run it, program makes it to its end and does not get any exceptions because we have handled every exception. We've handled the null pointer at position 1, and we've handled that position 2 through 99 are invalid indexes. One thing that you can do as sort of a fail-safe is you can put a catch exception E, and then display something like unknown exception. Or other exception. Now, if I don't have an exception catch clause for the exception, when I get that second kind, it'll hit this exception. Remember, these other two things inherit from the exception class. And we get displayed other exception for the rest of them. Because actually it's a invalid index exception, but we're not looking for that one specifically. The nice thing is you have the ability to fine-tune your exception handling. If you want to treat different exceptions differently, you can do so. That way I can treat the null pointer exception one way and treat the index out of bounds exception another way by displaying different messages or whatever. And if it's another exception, I can display other exception. So to summarize, everything in the try catch block gets executed. If somewhere in that try block is executed, then the Java virtual machine will go down the different catch clauses until it finds something that catches that exception. So if it's a null pointer exception, it will execute that. If it is an index out of bounds exception, it will execute that. If it is just a plain old exception, that is any exception other than these two, it will catch it here. Now, I'm just doing a printout here because it's a very simple example. But in reality, you might have different actions that can be taken. For example, out of GUI. All right, if in a GUI you entered in a value that was supposed to be a number and you got a number format exception, you might change a variable in there to say, hey, value entered must be a number, and then display that on the screen. This try catch is going to go in my test unit test class. You're not going to have catches in you're not often going to have catches in your business classes. It'll be up to whatever is running the show, either the GUI or the unit test class, to determine how these exceptions get handled. Let's look at another example. Here I have a triangle class. Okay, let's look at the triangle class and let's look at the unit test for it. Now, what do we know about triangles? We know this about triangles: that the sum of two sides can never be less than the sum of the third side. Let me show you what I mean. Is this a valid triangle? A triangle that has one side of 3, second side of 3, the third side of 3? Yes, it is, because these two sides add up to 6, and 6 is less than, or 6 is greater than the other side. These two sides add up to 6, and 6 is greater than the other side. These two sides add up to 6, and 6 is greater than the other side. What we couldn't have is this. That's not legal for a triangle. Why not? Because these two sides add up to 2, and 2 is less than the third side. So if we have a triangle with 3 sides, A, B, and C, A plus B has got to be greater than C. A plus C has to be greater than B. A plus C, or A plus B plus C has to be greater than A. If it meets these criteria, then it's a valid triangle. If either of these criteria are false, then it's not valid. So let's look at the code I have. All right, I have my triangle class. I put in the triangle class in the constructor, I say that it can throw an exception. Remember, someone has to catch the exception, whether it be your code or the Java virtual machine. So in this class, I call the constructor and give it a value for side A, B, and C. I go and set the values. Then I check to see if either of these are true. And if any of these are true, I throw a new exception. I also do that if I try to set an individual side at being less than 0 or less than 1. Can't have a 0 length side on a triangle. So I have my test. If it's invalid, I throw an exception. I then have to specify that this throws an exception. In my unit test, we're going to do a few different things. I create my triangle. T equals new triangle IJK. Well, you can see right off, this is going to be invalid. That's going to throw an exception. All right. What kind of exception? Specifically a number format exception. So the way this code is written now, this first line throws an exception. We do not continue with the rest of the try clause, but we hit the catch clause for number format. And we display e.toString. And we display a description of our own saying the code is written for a number format. In other words, the sides have to be numbers. So let's run this and check this out now and make sure we understand what's going on. We get a number format exception for input string hello, and we get code specifically written for number format. So this line throws an exception. We jump to the number format exception, display e.toString. When I say catch number format exception e, we're putting that exception in a variable called e, which is of type exception, and we can do things to it. We can output toString and show concise description of what went wrong. And then the program stops executing because that's all we did. All right, let's change this to 6. Now, we're not going to get that exception anymore, but let's see what happens. Java exception, each side must be greater than the sum of the other sides. How did that happen? Well, let's follow the code. I create an integer object, which is a new integer 6. Int and integer are object versions of the int, or integer is the object version of the int. That's required because certain things like array lists require objects, and so you can't put primitives in the array list. In this case, I create these integers, that's valid. I try to create the new triangle with the values of I, J, and K. Notice they're expecting ints, not integer, but through the process of boxing and unboxing, that integer gets converted to an int automatically. I set the sides, I then do the math, and one of these is not going to be true, or it's going to be true rather. Side 1 plus 2 is not, or side 3 is greater than side 1 plus side 2. Side 3 is greater than side 2 plus side 1. Therefore, I throw this exception, and it's just an exception. I'm not throwing a specific type of exception. I simply put each side must be less than the sum of other sides. I threw an exception. It's not a null pointer exception. It's not a number format exception. It's just a plain old exception. So I output the value to string. And this is not one of the two exceptions I maybe expect is the wrong word. I tested for. Might be a better use of that. Now let's say I put in a negative number here. Can't have a negative length of something. My code checks for that. Side 3 is invalid. This is not one of the two exceptions I tested for. It's just a plain old exception. It's not a number format exception or a null pointer exception. Tried to set it where it's less than 1. And it gives me that the argument is less than 1. Actually, there's a small bug in this program. This if statement here should really be, I'll tell you what, I'll let you figure out what the issue is with this. The problem is if I could create a valid triangle. Never mind, spoiler alert, I'll tell you the problem. The problem is I could create a triangle that was correct and then call a set method to set an individual side that would make those 3 triangles not correct. Make those 3 sides not correct. So I could initialize it as a valid triangle, and then I could change one of the sides and make it invalid. But if I go in and I create a valid triangle, then none of these exceptions are going to get called. And I'll be able to determine the perimeter. Okay, maybe not. Oh. Mistake. That was valid. That wasn't. I didn't look very close. And it works without an exception and displays the perimeter of the triangle is 9, which is correct. The last example, we're going to look at it, and you should take your time and study it in a little more detail. It's the same example, except I've created my own custom exceptions. So now, When I throw an exception, I can throw a triangle exception. I can control the particular new custom class that I have created. And what's the advantage of that? The advantage of that is that when I have it in a try-catch block, I can test specifically for that exception. And I know if it gets a triangle exception gets thrown, then I know it's a problem from the triangle class related to the code in the triangle class. Should be throws, not throw. Now, because I've thrown a specific kind of exception, if there's a problem, I can catch it. Now, what you have to do in your assignment is you have to change the student example to throw exceptions. And what you should have is a try-catch block around each of your test cases. So make up a student, add some classes to it. What are some of the things that you should test? You should make sure that the credit hours is not negative. There's no such thing as a negative 2 credit hour course. You should also test to make sure that a student gets a valid residency code. Those are 2 things I'm asking you to test for. If you want to test for more, you're welcome to do that. Those are 2 things that you should test for. You could, I would like you to try creating your own custom exception. If that's difficult for you, just create a regular exception, throw it, and then catch it. The throwing it will be in the student and the course class respectively. The catching will be in the unit test class. All right, that's all I had for today. Are there any questions? I am going from here into the lab. It'll take a couple minutes for me to get there, but if you do have any further questions, you're welcome to come and ask me in lab.